let's take a look at 619. And 619 is a graphics problem, and it's to define a class called polygon that has an arbitrary number of vertices, and then write a test harness, write test code that plots that uses the polygon class to display some polygon. So here we have a polygon class. So let's create the test code. So I went ahead, what I did was I copied one of the other projects and I renamed these polygon files. Here they are. So this is the cannonball problem. So let's rename these to polygon. This is the polygon. Here's the polygon constructor. And we're starting with the shell here. Well, we will have a plot function. Let's go ahead and put that in there. We'll have a polygon plot function. Let's stub it out. Just render a point at the origin. So we'll need this this plot function. Const means the plot function does not change the internal state of the object. The internal state is represented by the variables, the member variables in a class. So this is a promise that we're making to the compiler that we will not modify the member variables of the polygon class. That helps us catch logic errors. So we create a polygon. And we render it. Okay, there it is. We create a polygon and then render it. Now, what we're going to do is when we create this polygon, we need to add points to it. Say, we'll call it add vertex. We'll add a vertex, and we'll pass in points. So we'll have a vertex at, say, let's do a diamond. So -1, 0. You can just imagine what this looks like. -1, 0, 0, 1, and 0, 1, and then 0. Wait a minute. -1, 0, 0, 1, 1, 0, and 0, -1. Just had to think about that. So add vertex. We're going to need add vertex. And add vertex takes a point. So you'll see there's no compilation error, but we'll have a linkage failure because we didn't define add vertex. So we can compile, but we cannot link. Fatal error, unresolved externals. So we need to implement add vertex. And let's just do nothing, just to see if we can get a build. Good. Now the vertices are points. We're passing in the points. So let's go ahead and store the points. So now there's going to be an arbitrary number of vertices. Obviously the test code only uses 4, but we're going to create additional test code that draws different polygons. So we need an arbitrary number of vertices. So we'll use a vector of point called vertices. And every time, we're going to need that header file. And that looks good. Every time we add a vertex, we'll push it back onto our vector. I called it a point, didn't I? I think I'm going to call it a vertex here. I think that's better documentation. It still builds without, if you can call it a point, just I don't think it's as expressive as calling it a vertex. And so we're going to have some kind of a loop here. Let's go ahead and do the loop. It's going to look something like, we can use a for loop. We'll just get warmed up here. This is not working well for me today. Let's just output the vertex. Let's not draw the lines yet. Let's just plot that vertex at not 0, but at I. There it is. Now we need to get the lines in there. So, so to make a line, we need two vertices. So what if we did something like this? Let's output, instead of a point, let's output a line starting at vertex I and ending at vertex I plus 1. I like spaces. Anybody know there's a problem here? I think this will crash. Because the index I will, in our test case, vertices.size is 4. So that means I will eventually reach 3, and this code will run when I is 3. When I is 3, vertices of 3 is okay. That's the last vertex in the vector. But here, vertices of 3 plus 1, that's vertices of 4, that's the vertex at position 4 is undefined because the array is only of the vector is only of size 4. That means the the last valid index is 3. Let's see this fail. This builds. But when we run, vector subscript out of range. So we're going to need to stop a little early here. Let's stop at vertices.size -1. And what we need to do is we have to get the problem is we have to get the last vertex. It's that the last vertex is would be, it would, if we hard code it in there, it would look like this. It would go from 3 to 0. That's to close the loop. This will work with the test code, but it won't work in the general case. That works with the test code. So how do we make it work in the general case? Well, 3 is vertices size -1, and that allows the number of vertices to change. But we'll always get the last valid index in this expression. Let's expand the test code. Let's create polygon 2. And let's just all kinds of stuff. Actually, we can create an invalid polygon pretty easily here. No. I plotted polygon 1 2 times. There we go. So now it's working. There is one problem though. Let's be thorough about this. Let's create test code that will fail. Suppose we had a polygon of size 2. Is that a polygon? Can you have a polygon with 2 sides? Is that an invalid polygon? Yeah. Let's see what happens here. It doesn't fail on us, but it should, right? So this is minus. I'm going to do -9 like that. It's probably drawing one line. But am I calling the wrong thing again? I didn't call plot. And that should be 3. So that's an invalid polygon. So let's think about how we're going to do that. See, so let's suppose we'll catch that here. We'll have a condition. If vertices.size is less than 3, then it's a bad polygon. So what do? We do a message, right? cwin message bad polygon. Maybe you won't make it a sentence there. Bad polygon. What's wrong with message? I have to give it a point? I thought it had a default location. Oh, it still draws it though. So what we can do is return at this point. There we go. Any questions on this problem? Does everybody understand what const means? Can I do this? Can I declare add vertex const? Apparently not. Why? Why does that fail? We're still alive. Why does that not compile? What does const mean anyway? Const is a promise that you make to the compiler. You say, I promise not to write code in this function that's declared as const. I promise not to write code that modifies or could modify the value of any member variable in the class. But look, we're modifying vertices. We're changing one of, this polygon class only has one member variable right here. And we're changing it right inside the function. So it doesn't compile. But of course, if we take that out, we say, sorry, we've broken the promise. Now we're going to implement what we said. Now we compile. So const, it's an aid. It's a programmer's aid to catch logic errors, errors in reasoning. If you think that a function should not modify the state of a class or an object created from the class, then declare it const to enforce what you know to be true. It's similar to an assertion. In the test code that we looked at, it's similar to an assertion.